Hello children, this is the video on coordination compounds. It is the chapter under Inorganic Chemistry class 12th. Coordination compounds are also known as complex compounds, and they are those molecular or addition compounds in which central metal atom or ion is permanently attached to certain atom or group of atoms called ligands. Example, K4FeCN6, tetraamine copper sulfate. Now when you see both the compounds, you see the identity which is written in square bracket. That is the complex part of the coordination compound. In K4FeCN6, FeCN6 is under the square bracket. So, a coordination compound has that identity in which there is a central metal atom. In the first case, Fe is the central metal atom, and it is surrounded by a group of atoms which is called the ligand. So, in the first case, potassium ferrocyanide. In the first case, the ligand is CN, cyanide. And in the second example, tetraamine copper sulfate, you can see the identity in the square bracket. The identity in the square bracket is the complex part of the compound. Here also, you can see copper as the central metal atom, which is surrounded by amine. How many amine ligands? It's 4. Now, if we take a simple molecule like KCl, it just ionizes in water to give K plus and Cl minus ions. But if we take a coordination compound, like for example K4FeCN6, you see that the part which is there in the square bracket do not ionize. So, the ionization end of this K4FeCN6 is K plus, which is a simple cation, and FeCN6 4 minus. Now, if you see the example again, K4FeCN6, the ionization end, it is K plus, FeCN6 4 minus. FeCN6 4 minus is the complex part of the compound. This complex part has a central metal atom or ion, that is Fe, and 6 Cn minus ions which are called the ligands. Now, what is the speciality of the central metal atom? The central metal atom should have vacant orbitals, vacant d orbitals especially, which can accept electron pairs from the ligands via coordinate bond. So, the complex end has the central metal ion, which is permanently attached to the ligands via coordinate. Now, what we have seen is the central metal atom is a transition element. Ligands are atoms or group of atoms that can donate electron pairs to the central metal atom. Examples of some coordination compounds are diamine silver chloride, hexaamine cobalt chloride, potassium dicyanoargentate. Now, in the recent books, you can see cyanido in place of cyano. The most important part is the complex part is always written in the square bracket. Some of the important terms used in the coordination chemistry are central metal atom or ion, the ligands. As you all know, it's a molecular ionic species which get directly attached to the central metal atom or ion during the formation of complex. The coordination entity of the complex ion. What is the coordination entity? It's the electrically charged species formed by the union of central metal atom or ion with one or more ligands. Example, diamine silver ion, dicyano silver ion. Now, diamine silver ion is a cationic complex and dicyano silver ion is the anionic complex. Well, you can also say as dicyanido silver ion, as some of the books has CN written as cyanido. Coordination sphere and ionic sphere. The part consisting of central metal atom and ligands directly attached and enclosed in the square bracket is known as the coordination sphere. And the part outside the coordination sphere which get ionized in the solution is called ionization sphere. Well, what all is written in the square bracket, that is the coordination sphere, do not get ionized. And what is outside the coordination sphere gets ionized. As for example, hexa aqua iron trichloride. Hexa aqua iron is the part which is there in the coordination sphere, and chloride is the part which is there in the ionization sphere. So when it ionizes, it gives you FeH2O whole 6 plus 3 in the coordination sphere and 3Cl minus outside the coordination sphere, that is the ionic sphere. Types of complexes. In this you have cationic complex. For example, hexa aqua iron trichloride, when it ionizes, the complex end is FeH2O whole 6 plus 3. So it is a cationic complex. Next is the anionic complex, which is K2HgI4. When it ionizes, it gives a simple cation and the complex anion, which is tetraiodomercurate 2. And then you have neutral complex. One example of neutral complex is PTNS3 whole twice Cl2, where the whole identity is written in the coordination sphere. So these are the types of complexes. Now I'll go to the next one. Coordination number. What is a coordination number? The maximum number of ligands which can be coordinated to central metal atom or ion is known as coordination number. For example, in K4FeCN6, inside the coordination sphere, the central metal ion is surrounded by 6 ligands, 6 cyanide ligands. So coordination number of Fe is 6. And the second case, which is CuNH3 whole 4 SO4 tetraamine copper sulfate. Copper is surrounded by 4 ligands, so the coordination number is 4. And the next one, PtCl64 minus, in which platinum is surrounded by 6 cyanide chloride ions. So the coordination number of Cl is we'll go with the charge number of the complex ion. What is the charge number of the complex ion? It is the net charge carried by a complex ion, that is It is the algebraic sum of the charges carried by the central metal ion and the ligands attached to it. If we want to see the charge number of FeCN6, what we have to do is, you just check in the charge of Fe, which is plus 2. So it is plus 2 plus each Cn carries a single negative charge. And how many Cn ligands are there? There are 6. So it's plus 2 plus 6 into minus 1, and the total charge carried by the ion, the complex ion, is minus 4. See, what is the oxidation number of central metal ion? The oxidation number of central metal ion is the number which represents the electrical charge which the central metal atom has or appears to have when combined with other atom or group of atom. Example, if I take the whole compound K4FeCN6 and I want to check in the oxidation number of Fe, I know potassium, the oxidation number is plus 1. So I write 4 into plus 1 plus X, where I want to find out the oxidation number of central metal ion, plus 6 into minus 1. Minus 1 is the charge which is carried by Cn ion. And in totality, the compound do not carry any charge, so I write down 0. So what is the central metal ion oxidation number coming out to be? It comes out to be plus 2. So the oxidation number of the central metal ion is always positive.